Hi students, this is Sivakumar. 11th standard mathematics, chapter number 3, continuation of exercise 3.8, no problem number 3. Solve the following equations. Totally we have 11 subdivisions. We can do one by one. Here we have question number 3, subdivision number 1. Here in between the trigonometric functions we have the sign minus. So you have to apply sin C minus sin D identity. We know that sin C minus sin D, that is equal to 2 cos of C plus D by 2 into sin of C minus D by 2. Here C that is equal to 5x and D that is equal to x. So 2 cos C plus D, 5x plus x divided by 2 sin C minus D by 2, that is 5x minus x by 2, that is equal to cos 3x, which implies 2 cos of 5x plus x, that is equal to 6x by 2, that is equal to 3x, sin 5x minus 1x equal to 4x by 2, that is equal to 2x. It comes left hand side minus cos 3x, that is equal to 0. Between these two you can take cos 3x as common. Cos 3x into here 2 sin 2x minus, since we have taken cos 3x as common, here 1 will be there, that is equal to 0. Product of these two equals 0 means either cos 3x equals 0 or 2 sin 2x minus 1 equals 0. Double cases, case 1 and case 2. Case 1, cos 3x, that is equal to 0. Here you are not given any interval in that question. So you have tried the general solution. Remember, for all the problems you have tried the general solution only. In the previous problem you were given that interval 0 to 360 degree. Do you remember? The previous problem you are given 0 to 360 degree. Here if you are not given one, you have tried the general solution for all the problems. Here cos 3x, that is equal to 0. We know that if cos theta equals 0, then theta that is equal to 2n pi 2n plus 1 into pi by 2, where n belongs to integer. That's the general solution. So instead of theta we have 3x, which implies this is theta. So instead of theta equals, that is 3x equals 2n plus 1 into pi by 2. We need x. Therefore x equals 2n plus 1 into pi divided by 3 2s are 6. N belongs to integer. Case 1 over. Now case 2, 2 sin 2x minus 1 equals 0. Case 2, 2 sin 2x minus 1 equals 0, which implies 2 sin 2x, that is equal to plus 1 comes right, minus 1 comes right hand side, plus 1, which implies sin 2x, that is equal to 1 by 2. We know that the principal value of sine between minus 90 and plus 90. Sine is here. Since it is positive greater than 0, definitely it lies in first quadrant, not in fourth quadrant. Fourth quadrant sign is negative, right, which is greater than 0, which implies sin 2x, that is equal to, since the angle in first quadrant you have tried sin pi by 6. Pi by 6, that is equal to 30 degrees. Sin 30, that is equal to 1 by 2. 30 degree lies in which quadrant? First quadrant. Okay. Now what form it is? This is of the form sin theta, that is equal to sin alpha. We know that If sin theta equals sin alpha, we know that if sin theta that is equal to sin alpha, then theta that is equal to n pi plus minus 1 power n into alpha. N belongs to integers, set of all integers. Instead of theta we have 2x. This is theta, this one is alpha. So which implies theta equals, instead of theta we have 2x, that is equal to n pi plus minus 1 power n into alpha. Alpha that is equal to pi by 6, which implies x equals, have to divide here. If we divide now, you'll be getting n pi by 2 plus minus 1 power n. Here also have to divide because in between we have plus symbol, both to be divided by 2. 2 6 are 12. N belongs to set of all integer. That's all. Subdivision 1 is over. Then I'll be teaching that subdivision number 2 in the next video. Thank you, children.